No, we finished that, didn't we?
We didn't do this part.
Okay, we'll finish that after this.
Okay.
Finish that after this.
So
This
are we
is-
just on paper?
So this is regular paper, all right?
So we haven't started. This isn't like continuation.
Well, it's kind of just like the official trends, all right?
Official.
This is one question for AP.
So
Question number 2.
here are the official periodic trends that you have to be responsible for in AP chemistry. And just having arrows means literally nothing, all right? Just having arrows means literally nothing. So we're going to start out with atomic radius or size. So trend number 1 is atomic radius slash size. Atomic radius slash size. So we've already kind of discovered this trend, and we know that as I'm moving down a column, what happens to my atomic radius? It gets increases, right? My atomic radius increases as I move down a column. Why? Here's why. Number 1, what am I adding as I move down a column? I'm adding more shells slash shielding. So I'm adding more shells slash shielding, which means my distance from the core charge is going to increase. Yes. While at the same time, my core charge is what? My core charge is constant. My core charge is constant, which means my net nuclear pole, the net nuclear pole as I go down the group is going to be increasing or decreasing? Decreasing. My net nuclear pole is decreasing. And that is why atomic radius, as I move down a group, it gets larger. As I move across a period, what happens to atomic radius? We kind of already know this. It's going to get smaller, yes. My goal was kind of for you guys to kind of discover this a little bit on your own before we talked about it. Why? Well, number 1, there's the same amount of shielding. So my distance is not changing. Well, that's number 2. That means the distance from the core charge, is constant. And because of that, well, also, if my core charge is going up, my number of protons slash core charge is doing what as I move to the right? It is increasing. I'm getting more protons as I move across a periodic table. And because of that, my net nuclear pole is going to do what? Increase. Hence, that's why they get smaller, because it's pulling them in tighter as I move across to the right of the periodic table. So, whenever you are describing a trend, you are talking about 2 things every time. You're talking about core charge, and you're talking about shielding. So you cannot answer a question about a trend unless you're talking about those 2 things. You should say, is core charge increasing, decreasing, or constant? You should talk about shielding. Is it increasing, decreasing, or is it constant? And if you understand those 2 things, you understand all of the trends. You understand all of the trends. Trend number 2. So I'm going to put a little squiggle. Very pretty. I thought it was too. Trend number 2, it does.
Except for that incomplete sentence.
Yeah, that incomplete sentence. Ionization energy. Guys, we have to plan Chemsgiving.
Yeah. That's right.
I was thinking about that. So probably we'll plan that starting Monday.
I know we'll be
Rose
safe.
giving Thanksgiving, actual Thanksgiving.
Ionization energy
You can bring the sweet baby rays.
is defined. I'm sponsored. Yes.
Sponsored by Sweet Baby Ray.
Is the energy. Teachers should get sponsored, all right?
Yeah.
If race car drivers get sponsored, why don't teachers get sponsored?
What?
Think about that.
High school athletes can make money out there, and there's so many teachers.
High school athletes can now?
If you're like a
Yeah.
5-star
Oh.
athlete, yeah.
ionization energy is the energy required to remove / eject, we'll say eject, an electron. That says an, not one. So the energy required to remove / eject an electron. So let's think about this. As I'm moving down a group, what is going to happen? Thank you. What's going to happen to my ionization energy? It's going to decrease. You got it. It's going to decrease. Why? What am I adding as I'm moving down the group?
Distance.
How am I adding distance? I'm adding
Shielding.
more shielding. I'm adding more shielding, which means my distance from the core charge is,
Increase.
does this look familiar? Yes. Therefore, the core charge, well, that's not a therefore. Also, the core charge is constant. The core charge is constant, which means my net nuclear pole is decreasing. So it is easier to remove an electron. So you can see it's the exact same explanation. It's the exact same explanation. But let's do it one more time just for funsies. You don't have to write it down if you don't want to. It's up to you. If you got it, I'm good with that. As I move across the periodic table, the ionization energy should increase, right? Now, caveat,
Oh no.
with kind of a little reset right here, right? Right here, there'd be a little reset.
What's going on?
Well, I want to lose an electron, lose an electron, lose an electron, lose or gain, and here I want to start gaining. It still works, but it just kind of like goes up a little bit and then goes back down. All right, it goes up a little bit, but the general trend is decrease. All right, because you're flipping what it wants to do at that point. So you have to think about the difference between metals and non-metals. But the general trend is it increases. It increases. Why? As I'm going across the period, what do I have the same amount of? I have the same, Brennan's not writing this down though. He's got it. The same amount of shielding. All right, the same amount of shielding. So my distance to the core charge is constant. My distance to the core charge is constant. But what's going up as I'm going across?
The core charge?
The number of protons / core charge
Right, Brendan?
is increasing. He's got it.
Oh, he's right.
I'm just drawing a big arrow.
That's fine. And then number 4, this means that my net nuclear pole is increasing. Therefore, it is harder to do what?
Eject.
To remove or eject an electron.
Should we put that at the top on this one?
What's the question?
Did we write that for the first one?
Up here?
Yeah.
You could have put therefore size is getting larger, or therefore. I'm going to show you how I want you to question Jacob. Yes.
I was just a little distracted.
Me too.
So if the trend kind of flips in like group 15-ish, is the net nuclear pole decreasing at that point?
The net nuclear pole is still increasing because I'm still getting more protons.
Then how is it easier to eject an electron? Is the right then?
So carbon, let's just say, so let's go period 2.
Okay.
Lithium loses 1, right?
Right.
Beryllium loses 2.
Right.
Boron loses 3.
Right.
Carbon loses 4.
Yeah.
But nitrogen wants to
Gain.
gain 3. And we're talking about the energy required to remove an electron. So nitrogen's is going to be a little bit higher because it doesn't even want to lose an electron, right? Wait, let me think about that. Nitrogen's will be even... No, nitrogen's would be even lower, right? I got to think about this. I don't want to confuse myself. lose 1, lose 2, lose 3, lose 4. Nitrogen wants to gain 3. So the energy required to remove an electron would be even lower, right?
What would cause it to be lower? Is the net nuclear cold decreasing from carbon to nitrogen?
No.
So the iodine.
No, I think that's actually,
Maybe it's-
pause. All right? Ignore what I said. All right, good. That works out, all right? That works out. I wasn't thinking of ionization energy. I was thinking of ionic radius.
Okay.
All right? I was thinking of ionic radius. So this should be pretty constant across. All right? Yes.
So with the radius, like the horizontal one, right?
Yes.
So it says distance from core charge is constant.
Correct.
But it can't be constant if it's getting smaller, right?
The distance, well, from the shielding, right? I'm talking about the shielding. It is getting smaller, yes. But the distance from the core charge in relation to the shield,
Oh, so the shield, the one.
it's just one shield. I'm not adding or taking away shields. That's what I'm talking about. For the distance. It is getting smaller, but I'm talking about the shield. So I'm not adding or subtracting shields. I'm staying all on one shield. Is that helpful? Okay. So ignore what I said, all right, about this. I was thinking of ionic radius. Because that
was
does,
in the packet too, right?
I believe so. All right? Because ionic radius does actually flip there, and we'll say why in a second. So, atomic radius, ionization energy. After that, as long as you understand the trend and what it is, it's all the same. All right? So, trend number 3 is called electronegativity. I know. Electronegativity, which is defined as the attraction for a bonding electron. This is literally the exact opposite of ionization energy, right? Ionization energy is the energy required to remove one, yes. This is saying the attraction for an electron, but what's the trend going to be? It's the same. It's the exact same trend for different reasons. Think about it, all right? This is the attraction for a bonding electron. So this is how much does it desire to gain an electron. So this is the exact same trend as ionization energy, right? Because if my ionization energy is going up as I'm going this way, well then my desire for an electron is also going to go up. It's the same trend. It's the same trend, just explained differently. All right? Head nod if you're okay with what I'm saying. Okay. So we're just going to draw arrows for this one. Okay? We're just going to draw arrows. So electronegativity, as it goes this way, should increase. As it goes this way, it should decrease. If you just do arrows from the beginning, I don't know. That'd be rough. That'd be rough.
Yeah, that's all we do in CPK.
But I kind of understood it.
You have to understand this why, or it's very difficult. So that's electronegativity. Another one would be reactivity. My pen is falling apart. This Ashland University pen is not great. But the cookie was good.
The cookie was crazy.
You can throw a big stick at you.
I'm good. I'm going to persevere through this.
Jake has
They gave us
some-
cookies at Ashland yesterday this big.
They were big as me.
Is that an exaggeration?
I hear,
No,
I hear
no.
they knocked some folks
Were
out.
you tired yesterday when you got back?
No.
That was the
You're
worst.
the only one. I don't know why, but everyone, even Mr. Ward said he was nodding off, like in class. Like,
Well, all of you ate like 2 huge sandwiches at lunch.
That's true. That means
So-
we are
That was the
figuring out
Where did you have
reasons,
lunch?
but-
We went to Wendy's.
Yeah.
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 We went to Wendy's.
Those were the worst 2 periods of my life.
I'm gonna flip the page.
What?
All right. Next one would be
None.
reactivity
Are they?
of metals.
Let's go.
Reactivity of metals. We already know this trend.
Wait, Eric, what is
Because we know that metals want to do what with electrons?
Give them away.
They want to give away electrons, yes? So as I'm going down a group, my reactivity of metals is going to, think about it, increase. Right? It's going to increase. Because I'm adding more shielding, yes?
Yes.
Same core charge, it can more easily give away an electron. As I'm going this way, it's going to decrease. Because now, as I'm moving to the right, it's holding onto those electrons more. I always feel like it's like face mask when I'm doing this. All right, nonmetals. Reactivity of nonmetals, you can imagine, is going to be the opposite, right? Because nonmetals want to do what with electrons? Gain. So as I'm going down a group, it's going to decrease. It's going to decrease, and as I go across a group, it's going to
Increase.
It's going to increase.
This makes so much more sense now.
Good.
What was that one?
Good.
Wait, Eric, what was this one?
Good. Last one.
Does this one increase?
Almost the last one. Electron affinity. Electron affinity is equal to the amount, this isn't hard, the amount of energy released, when a neutral atom gains an electron. The amount of energy released when a neutral atom gains an electron. So, this is kind of just a different way to describe electronegativity. It's just a different term, in all honesty. All right? Because when you gain an electron, you're going to gain it because you're electronegative, right? So this is just another way to describe it. So the trend is the same. As it goes to the right, it's going to increase. As it goes down, it's going to decrease. But what you may see is something like this. So X, gas, plus an electron gives you X minus gas. So sometimes you'll see an actual equation that goes with this for electron affinity, and they can be like, solve for it. Or you might even see something like this. So if I have fluorine gas plus it gains an electron, that gives me F minus gas, and then the energy of this equation is equal to negative 328 kilojoules per mole. So sometimes they'll even give you a numerical value with that.
What would we be doing with that?
What would you do with that? I mean, it's kind of like, it'd be like if you could, okay, here's what you do with that. It would give you this number and be like, what if it gains 2 electrons?
Is it
Double?
It just doubles it. Yep.
What's the thing next to the E?
E minus?
No,
Final
the
E.
final E. The spider.
EEQ equation. Energy of this equation.
EEQ.
Yeah, of course.
You guys resume
I thought it was
Guys,
an
just look at that.
That looks like glasses.
That says EEQ.
If you don't have to have
What?
20.6, wow.
I would.
Obvi.
Yeah.
All right?
We thought
EEQ.
it was an M or a spider.
I thought it was an M.
That is bad. That is bad.
It's better than my hand.
So what would you do with that? They would give you that and be like, what if it gained 3 electrons? Well, then you'd multiply it by 3.
Oh, that's really
That's
easy.
all you're doing with that.
We should
Okay?
have a test on just that.
Last one is ionic radius. Ionic radius. So this is not hard, but you have to be able to define what's going on. So a cation. How do you become a cation? First of all, it has what type of charge?
Positive.
Cation is positive,
Cats are
right?
positive good.
Because cats are positive. Yes. And a cation did what with electrons?
Lost.
It
Cats
lost
off the table.
electrons. So, what is going to happen to the ionic radius of a cation? Think about this. It's going to decrease.
Wait, say it again.
What is going to happen to the ionic radius of a cation if it loses electrons?
Decrease.
It's going to decrease. For example, let's say beryllium. Beryllium forms what charge?
2+.
Plus 2, because it wants to lose how many electrons?
Yes.
If it loses 2 electrons, it has now lost a whole level of shielding.
Okay.
Right?
I can see
So let me draw that. So here it is. Here's beryllium. Has 2 in the first shell. It has 2 in the second shell. it is easier to lose 2 than gain 6, right?
Yeah.
That's right.
So after beryllium becomes a 2 plus and it loses those 2 electrons, it is losing a whole shell. So ionic radius for a cation is smaller,
And if it lost 1, it would still marginally decrease, right?
marginally,
Yeah.
right? Because it have more protons, right?
Huh.
Now it have an imbalance of protons.
Pull it in more.
You got it. Also, that would be like, if I said something like beryllium, why is the third ionization energy for beryllium so much higher than the second?
It's right in.
Because after I lose 1, right, it's about the same. I lose 2, it's about the same. But after that, now look how much closer to the nucleus they are. I lost a whole level. Now, so ionic radius for a cation increases. I'm sorry, decreases. We just said that, it decreases. So ionic radius for a cation decreases. Now, let's talk about an anion, because it's not what you expect. I mean, it is, but not for the right reason, probably. Yes,
Whoa.
it is decreasing, because an anion is a negative charge, which means it gains electrons. So why would the ionic radius increase for an anion?
Oh, it increases. Is it because they're being?
It does increase.
Are they being repelled by each other?
Ah, shoot, you guys are too smart. All right, fluorine, first level has 2. Second level has 3, 4, 5, 6, 7, right?
Mr. Word.
What is it? They're blue?
They're even smart people goggles.
Wait.
Even smarter.
Whoa.
So we got all 3 colors this time.
That's
goggles.
awesome.
Infinity goggles.
That's really
I thought you were coming to tell me you tried the suit.
Haven't got that far yet. I
Okay.
haven't made that in my room.
Okay.
Your 50 ml burettes that we ordered, the 2 of them, came in shattered.
Oh,
No.
Totally smashed.
we can tell them.
Yeah, I told Pam to let him know, but you won't have those for who knows how long.
Okay. You guys know what he's talking about, the things that connect to the pipetters?
That's so sad.
Was it
Yeah.
UPS or USPS?
I don't know. I don't know.
Yeah, who's this?
So,
I like the colors. Those are cool.
those are cool. Those are cool. Just general.
Oh.
All right. So,
They don't get cool goggles.
No.
well, now like they're making them all like that. So, but you guys were the first ones to have it,
That's really
and you guys get to keep yours.
That's right.
We'll do a whole goggle ceremony at the end of the year. It's very emotional. It's fun. All right. So, let's go back to this. Fluorine wants to do what with 1 electron? It wants to gain. So, I can't really draw this, but it gains an electron. Well, now I technically have more repulsion on this outer ring, right? Did my shielding change?
No.
No, it didn't. But I added a more negative charge here, and negative charges want to repel. Same amount of protons also. So, for an anion, as I'm gaining more outer electrons, they want to repel further away. That is why an anion gets larger. That's why an anion gets larger. So an anion gains electrons, so it increases. It increases. Also, yeah, that's it. That's it. So what would I ask you on like a test? Because we have a test coming up Thursday. Officially. Thursday.
Just wait.
So I could ask you something like this. This pen is done. Trash. So close. All right. What has a higher ionization energy? Na or P and Y. So what has a higher ionization energy? Na or P and Y. Here's how I want you to answer this. This is how you should answer it on an AP test. Would they ask you this on an AP test? No, too basic. All right. But here we go. The first thing I want you to do, number 1, is write the answer. So the correct answer is
P.
higher ionization energy.
I was thinking lower.
Higher ionization energy is P. Also, for what I just talked about, do you guys now see what I was thinking for the reset, right? The reset happens here for ionic
Ionic
radius.
radius,
Yes.
Because they're gating ions.
Correct. Yes.
And they have
So it goes do 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 do
Yeah,
do, and then
repelling
boom,
force.
right, and then do do do.
Dude, whoever made the period.
There's probably a picture in your book of that.
What's group 14? Like,
It's between group 14 and 15 where that little reset is.
Does like carbon form both kinds of ions? Or
It
silicon?
generally gains,
Okay.
but it depends. We'll get into more of that. We're getting close. All right, we're getting close.
When do we get into real chem?
After this chapter.
Uh-oh.
Yeah. This is gonna be an easy test for you
Do
guys.
we have a real chem test before Thanksgiving?
One.
Oh.
Oh, before Thanksgiving?
Yeah.
Well, no.
So this is the last test.
We only have a week after
Okay.
this.
Okay.
Because we have a week and we have 1 day, then Chem's giving.
Okay.
So,
Oh, yeah, you're right.
yeah.
I feel ready.
So I did just kind of extrapolate out till the semester. The last 3 days, not going to be the most fun, but that's okay. So it's going to end like this. It's going to end test Friday, midterm Monday, midterm Tuesday. So
Handle that.
We have interns?
we do.
I
Yeah.
thought told there was no midterms this year.
Oh, there's not?
Says who?
Mr. Messer said.
Yeah.
There's no interim grades. Maybe there's not. If there's no midterm, I won't give you one. But
Yo, wait.
it depends. Whatever they tell me to do. But that's what it looks like now.
It was Miss Heiner. What is our midterm? Like, is it?
The midterm is everything we've done so far. But remember, there's no final. Well, there's a final, but it's a lab notebook.
Yeah. No, I'm okay
And-
with that, but man, that would be pretty nifty if we didn't have to have them.
If they tell me not to give one, I won't give one. Because obviously, I don't want to waste time giving a 2-day test.
Yeah.
Because I cannot give a midterm in here in 1 day.
Well, I think that's why they were doing it is because
Right,
we
yeah.
Right about
anyways. 'Cause
You guys find out and let me know.
Yeah.
What's Mr. Ellis?
Let me know.
That's the only question on the
If I don't have to give a test, I won't give it.
Yeah,
Okay?
that's what your birthday is.
Can you
though.
take thermocam
Yeah.
off of it?
It's
What's
already
that?
the 23rd.
Can you take thermocam off of it?
Take thermocam? No.
Dang.
But the good thing is it'll just be like basically one question from each chapter because what else could I do? I mean, these can be pretty involved. So, step 1, answer.
Just gives us 8
Step 2, define the trend. Define the trend. So, the definition of ionization energy is, you would say, ionization energy is the energy required to do what?
Eject an electron.
To eject or remove an electron. To remove an electron. So I define the trend. And then number 3 is why. Number 3 is why. So each one of these, guess how many points it's usually worth?
1, 2, and 3.
5. Wait, 4.
Yeah.
That makes
1 point for the answer, 1 point for defining the trend, and what 2 things do you have to talk about in the why? Core charge,
and
shielding. You guys got it. All right? Core charge and shielding. So why? Well, Na and P are in the same what? Period. So they have constant what? Shielding.
And increasing.
They have constant shielding. What's increasing? Right. Core charge is increasing. Therefore, harder to remove an electron from what? Phosphorus.
Alright, that was killer, I need a recipe.
How
I know.
amazing
I don't even
was
know about
that?
butternut squash was good. This is for Saturday school.
Oh, for one of your students?
One of Amy's.
Got it. Mr. Worth just tried my wife's butternut squash and chorizo soup.
Bring it to Thanksgiving.
It was good.
That
It's
was
got the pumpkin pie flavor in the beginning, and then all of a sudden the boom from the
the
cheese.
spice.
Good. So good.
So good.
I like that.
We share our soup recipes. We share our soups.
Whose turn? Is it his turn next? then?
It's his turn now.
What's
yeah.
he bringing?
Well, the last one he brought me was like a pulled pork soup.
Oh, that's right. I remember that.
Did he bring that in this class?
He did.
Yeah.
So, I'm working on a beef and barley recipe right now. So, So that's it.
Core charge is increasing.
So that's it. So I said core charge is increasing. How to remove an electron from potassium?
Potassium.
Potassium.
I'm sorry, phosphorus.
I was like, oh.
I'm teaching freshmen right now. It gets confusing. All right.
Okay.
It's actually super confusing because